Good morning, Geoscience. This is your M&M Half-Life Lab to help you understand radiometric and absolute dating. So this lab is available to you on Canvas under Age of Earth. And if we were in class, we would be able to do this lab, but we are currently not. And hopefully this will help you understand radiometric dating a little bit better. So let's take a look at the lab, and I'm going to tell you what to fill in for our lab. So it tells us that our topic question is, how do we know the age of Earth? And I wrote, this question will be answered after we are done with the lab. Okay, so we don't need to answer this question, but this is the goal. This is what we want to understand by doing the lab. Then the lab goes on to give you a little bit of background on both relative and radiometric dating and how they are the same and how they are different from each other. And in the lab, basically what we have is we're going to pretend that the cup is the rock, and inside of here are going to be your atoms. Okay, so the M side of the atom is going to be a radioactive element called eminentium, and the other side that doesn't have the M on it is a daughter isotope, and that is going to be blankdium. That's going to be the decay product. Okay, so in this lesson, your task is to investigate the research question, how do scientists know the exact age of rocks and fossils? So what you want to do is you want to read this information, and then you want to answer these two questions. Okay, so you need to answer this one, and you need to answer this one. And both of the answers are in here. Okay, so it shouldn't be too hard. Then you're going to make a prediction. For this lab, we will be working with a hypothetical element called eminentium, which is a part of this rock. Okay? And its half-life, and it has a half-life of 10 seconds. When eminentium is stable, it changes to blankdium. So I want to know, I think it will take blank half-lives for eminentium to turn into blankdium. So I want to know if I shake this and I dump it, and I only take out the ones with the M, and then I shake it and I dump it, and I shake it and I dump it. I want to know how many times until all of the M's turn around to the blank side. So how long will it take, or how many shakes will it take for all the eminentium to turn into blankdium? Okay, so you're going to write that number right here, and you're going to tell me why you think that. All right, so this is a prediction or hypothesis, so it does not matter if it is right or wrong, but you do need to take a guess. So you need to fill this in, and you need to tell me why you think it right here. Okay, lovely. So this was the pre-lab to give you kind of a background of what we are doing. Next, we have some materials that we're going to need, which I have right here. Also need a calculator. You're going to need a calculator too, but you can use one online or on your phone. And then we're going to follow the procedure. I wash my hands. I have my material. I have my M&Ms. I know which side is the parent or radioactive side, the eminentium, and I know which side is the daughter isotope or the stable blankdium. It says count how many M&Ms you have and put that in the data chart. So down here, I have a data table. You can see that they're kind of not connected. They're on separate pages, but I have a data table, and I put in data from last year. So this was group 1, group 2, and I left group 8 blank. We are going to be group 8. So I'm starting with 100 M&Ms. Okay, so you need to write that in as well. It says pour the M&Ms into a plastic container with a lid and shake it for 10 seconds. Pour the M&Ms onto the paper. I'm going to do it here. So here we go. Ooh. And I'm going to dump it. Okay, I'm going to move this out of the way, kind of shake them down. Okay, and then it says pick up and set aside only the M&Ms that are now stable daughter atoms. So what I'm going to do is I'm going to, the ones with the M side up, I'm going to put those over here. And the ones with the M side down, I'm going to put those over here. So I'm going to pause while I do that. Okay, I have now separated them into different piles. And then it says, count the number of pieces of candy left that still are radioactive parent isotopes and put that in your decay table. So we started out with 100. And when I counted these, we had 48. So this is going to be after our first shake, okay, our first half-life. So you see half-life over here. This is one half-life, and we have 48 of these M&Ms with the M&M face up. It says repeat the same procedure of shaking and counting only the radioactive parent isotopes 8 times. And then you're going to record them. So I'm going to take these, just the ones with the M side up. I'm going to put them back in the cup. And this is considered our rock, basically. And I'm just going to shake these. And I'm going to do the same process. So here we go. And I'm going to dump them. And now I'm going to do the same thing. I'm just going to remove the ones with an M. I'm going to separate them from the ones that are blank. All right, so for my second run, my second half-life over here, now I have 28 of the M and empty M remaining. Okay, so I'm going to keep going. All right, so for the third run, right here, third half-life, I now only have 10 remaining. So I'm going to do it again. I'm going to show you the last couple rounds, I think. Okay, so 1, 2, 3, 4, 5, 6. All right, so now I have 6 for my fourth half-life. I'm going to come over here and I'm going to write 6. I'm going to put these 6 back in. 4. And we have 1, 2, 3. Okay, so I'm going to write that in my data table right here. 3. All right, now I only have 1 left. So I am down here now on my 6th half-life. I'm going to write a 1. I'm going to shake it. And all right, now I'm at 0. So my 7th and 8th half-life, I have 0. Okay, so you can see that we have a lot of data here and a lot of this, excuse my, I was painting, so my nails look dirty, but they are actually just paint. We have class data. We can see that it's not exactly the same, right? There's a probability going on here. The same thing happens in rocks. It's not always going to be half every time for half-life. It's going to be close, but, you know, it's not going to be perfect. So the next thing that we're going to do is we need to calculate the class average, okay, for each half-life. So I'm going to do this one for you, and then you're going to do the rest. So I have 100 plus 100 plus 99 plus 100 plus 100 plus 100 plus 100 plus 100. So that's going to be plus 500. And then we have to divide it by the number of groups. So we have 8 groups. So we're going to take that number, divide it by 8, and we get a class average of 99.8. Okay? So you are going to find the class average for this one. You're going to add these up and divide by 8, add these up, divide by 8, and you are going to get class averages for each half-life. Then you're going to make this graph on a separate sheet of paper, and you're going to graph only the class average. Okay, that is the most accurate because it's been done many times. Okay, of just the parent isotope, which are these, all right? Separate sheet of paper, take a picture of it, put it in your drive, insert the document. This is how you set it up, so you don't need to worry about setting up a graph, okay? And then when you're done, you are going to answer these questions. It says, how many half-lives did it take the class to have about half the original parent isotope, M side up? So let me show you how to figure it out. You're going to go to your data table. You started with 100, and it's probably going to be about right here that you have around half, which is 50. So your answer for number 1 is going to be 1 half-life. Okay? So that should help you answer number 2 as well. And you should be able to answer these questions based on your notes, the rest of them. Okay? And just by thinking about things a little bit. If you have any questions, please let me know. But that is everything that you need to do. Remember, you don't need to do the lab. I did the lab for you. You just need to fill in the lab report. And when you're done, submit it on Canvas. Hope you have a good day.